Problem number 52, no numbers, we just have to derive formulas. We have a system of two objects connected with a string. We see that one of them is going through the change in potential gravitational energy because it loses height. And if it moves this distance of h, then this will also have gone that same distance horizontally. And we need to figure out the coefficient of kinetic friction for the block on the table, and we need to figure out the speed of the block just before it hits the floor, right? So I'm going to say that my gravitational energy turned into kinetic energy for the system, right? And there are two kinetic energies because I have two objects. They will be moving with the same speed because they're connected with a spring, So mgh initial will be equal to, I'm just going to write it out, will be equal to mv final squared over 2 plus little m v squared final over 2. And again, I said it's the same velocity, so I can just do v final squared over 2. And then it's the sum of masses, from where v final is going to be root of 2mgh initial, which is h, over m plus m. This was without friction, so this would be for B, technically. I started with the easy one. A, as far as A goes, then I would have to say UG plus work of friction will be my m plus m over 2 V final squared. Now, work of friction is going to be force of friction times H, because that's the distance traveled, times cosine of 180. So ultimately that gives me a negative. Force of friction is going to be, since it's the capital M, mg times mu k. So then, again, I start with little m g h plus, which is negative. Then I have to add the work, but I know cosine of 180 is going to give me a minus mu, capital M, g times h, which is displacement, will be equal to v final squared over 2 and times the big M plus little m. Then if I rearrange this, then it's going to be v final is going to be a root of, I'm going to put 2gh away, m minus mu kinetic m over m plus m. And that's the answer.